Hello, and today we will talk about the causes of climate change. Scientists attribute the global warming trend observed since the mid-20th century to the human expansion of the greenhouse effect. Warming that results when the atmosphere traps heat radiating from Earth toward space. This is a simplified animation of the greenhouse effect. Certain gases in the atmosphere block heat from escaping. Long-lived gases that remain semi-permanently in the atmosphere and do not respond physically or chemically to changes in temperature and described as forcing climate change. Gases such as water vapor, which responds physically or chemically to changes in temperature are seen as feedbacks. Gases that contribute to the greenhouse effect include water vapor, nitrous oxide, carbon dioxide, and methane. Also, water vapor, the most abundant greenhouse gas. But importantly, it acts as a feedback to the climate. Water vapor increases as the Earth's atmosphere warms. But so does the possibility of clouds and precipitation, making these some of the most important feedback mechanisms to the greenhouse effect. Carbon dioxide, a minor but very important component of the atmosphere. Carbon dioxide is released through natural processes, such as rapid respiration and volcanic eruptions, and through human activities such as deforestation, land use changes, etc. Humans have increased atmospheric carbon dioxide concentration by more than a third since the Industrial Revolution began. This is the most important long-life forcing of climate change. Methane is a hydrocarbon gas produced both through natural sources and human activities, including the composition of wastes at landfills, agriculture management associated with domestic livestock. On a molecule-for-molecule basis, methane is a far more active greenhouse gas than carbon dioxide, but also one which is less abundant in the atmosphere. Nitrous oxide, a powerful greenhouse gas produced by soil cultivation practices, especially the use of commercial and organic fertilizers. Fossil fuels combustion, nitric acid production, and biomass burning. Chlorofluorocarbons, CFCs, synthetic compounds entirely of industrial origin, used in a number of applications, but now largely regulated in production and release to the atmosphere by internal agreements for the ability to contribute to the destruction of the ozone layer. They are also greenhouse gases. Here are the two pictures of two planets in the solar system, Mars and Venus. Mars's greenhouse is not enough, so the planet Mars has a very thin atmosphere, nearly all carbon dioxide, because of the low atmospheric pressure, and with little to no methane or water vapor to reinforce the weight of greenhouse effect. Mars has ice caps that contain lifeless. Venus is direct opposite. Venus has too much greenhouse effect, 154,000 times as much carbon dioxide in its atmosphere as Earth, and about 19,000 times as much as Mars does, producing a runaway greenhouse effect and a surface temperature hot enough to melt lead. On Earth, humans' activities are changing the natural greenhouse. Over the last century, the burning fossil like coal and oil has increased the concentration of atmospheric carbon dioxide. This happens because the coal or oil burning process combines carbon with oxygen in air to make CO2. To a lesser extent, the clearing of land or agriculture, industry, and other human activities has increased concentrations of greenhouse gases. The consequences of changing the natural atmospheric greenhouse are difficult to predict, but certain effects seem likely. Earth will become warmer. Some regions may become warmer temperatures, but others may not. Warmer conditions will probably lead to more evaporation and precipitation overall, but individual regions will vary, some becoming wetter and others drier. A stronger greenhouse effect will warm the oceans and partially melt glaciers and other ice, increasing sea level. Ocean water also will expand if it warms, contributing further to sea level rise. Meanwhile, some crops and other plants may respond favorably to increased atmospheric CO2, growing more vigorously and using water more efficiently. At the same time, higher temperatures and shifting climate patterns may change the areas where crops grow best and affect the makeup of natural plant communities. The role of human activities. In its fifth assessment report, the Intergovernmental Panel on Climate Change, a group of 1,300 independent scientific experts from countries all over the world, under the auspices of the United Nations, concluded there's a more than 95% probability that human activities over the past 50 years have warmed our planet. The industrial activities that our modern civilizations depends upon have raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years. The panel also concludes there's a better than 95% probability that humans produce greenhouse gases such as carbon dioxide, methane, and nitrous oxide have been caused much of the observed increase in Earth temperatures over the past 50 years. The above graph compares global surface temperature changes, which is the red line, and the sun's energy that Earth receives, which is the yellow line, in watts, units of energy per square meter since 1880. The lighter, thinner line shows the yearly levels, while the heavier, thicker line shows the 11-year average change. 11-year averages are used to reduce the year-to-year natural noise in the data, making the underlying trends more obvious. The amount of solar energy that Earth receives has followed the sun's natural 11-year cycle of small ups and downs with no net increase since the 1950s. Over the same period, global temperature has risen markedly. It is therefore extremely unlikely that the sun has caused the observed global temperature warming trend over the past century. It is reasonable to assume that changes in the sun's energy output would cause the climate to change. Since the sun is the fundamental source of energy that drives our climate system, indeed, studies show that solar variability has played a role in past climate changes. For example, a decrease in Solar activity coupled with an increase in volcanic activity is thought to have helped trigger the Little Ice Age between approximately 1650 and 1850, with Greenland cooled from 1410 to the 1720s, and glaciers advanced in the Alps. But several lines of evidence show that the current global warming cannot be explained by changes in the energy of the sun. Since 1750, the average amount of energy coming from the sun either remained constant or increased slightly. If the warming were caused by a more active sun, then the scientists would expect to see warmer temperatures in all layers of the atmosphere. Instead, they have observed a cooling in the upper atmosphere and a warming at the surface and in the lower parts of the atmosphere. That's because greenhouse gases are trapping heat in the lower atmosphere. Climate models that include solar irradiance changes can reproduce the observed temperature trend over the past century or more without including a rise in greenhouse gases. Thanks for listening. Goodbye.